All right. So tonight, what I want to go over exactly what I just said, but you've got your objects built, that sort. With this current project, they're in different components. Not that they must be for printing, but it is certainly a helpful method of going about. But what I want to go about discussing is taking those objects and getting them printed for, or getting them prepped for printing in the slicer program, and how that relates to both how you should orient the object for the best potential for both success for printing and using the least amount of material. And that relates directly to scaffolding, printing supports. So first thing, let me open Fusion back up and we'll get this prepped. So working on the revolved vessel, I'm going to leave it with the text here. Pardon me. Super good as is. So for printing, first thing you want to note is when you're printing objects, there's a reason why you've seen objects with, actually, let me change my screen to just the whole screen. That will make it more effective for me to jump back and forth. All right. So you've seen objects that have a bunch of, looks like it's got a roller coaster built around your object. That is the supports, your scaffolding around the object, because obviously some things have to be supported because you're printing these objects in space, and space, at least on this planet, has gravity. So you can't have stuff just free floating and still be able to print it. So you have to actually have to have some supports. So first off, what that comes into is, well, how do I gauge all of that? Well, with something like this project and the way I've drawn this, it's pretty simple, at least in consideration, because right now, your supports will kick in if your object has an overhang. And an overhang is anything that really goes beyond a certain angle, starting from, if it's printing from the bottom up, like this will be printed. If this piece had, like, say, a lip hanging out in space, something like that, something that wouldn't be able to be sliced before, excuse me, wouldn't be able to be sliced without being supported. Pretty self-explanatory in that. Now, in this object, it's going to be oriented from the bottom up, and there really won't be much of an issue. However, the bottom is recessed, and there's also holes. If this were all flat on the bottom, like the first project, like the badge project, it's all basically flat on the bottom. No problem. It will directly go onto the print bed. But this has this large recess. Same thing with the tray. I built it in the same method just to show you how this all works. So with that, how can you solve this issue if you want to minimize the amount of support you have? Well, that comes down to how you put this on the print bed and also how you design stuff. If this were elaborate and had like a large overhang, you'd want to maybe minimize that overhang. But first, let's go about it with how we are actually discussing this. So for printing, in Fusion, you remember you have to actually select all the bodies and such, and then go out for it from there. So I'm going to select on my hierarchy tree vessel. I want just this one. They're different components, so you don't want to select the whole component, because if you have hidden objects or anything, it'll grab that too. That's why it's important to just grab the body. All right. Go to File, and we're going to go to 3D Print. Remember, we're going to deselect the 3D Print utility because we're just going to be using the Prusa. Double check your format. For these, again, it's fine if you're using STL or OBJs, but I know for myself, I'm getting myself in the habit of using 3MFs just because it's more universal. Select OK, and we got to go that. So give it a title, allo vessel. There we are. Now you want to make sure that you're getting both the tray and the cap, and the body, and the vessel. Now the trick to this is you want to make sure you're not getting both. Also, doesn't hurt to make sure you've got it titled. So tray certainly doesn't hurt. And the reason for this is if you select them both at the same time and bring them out for 3D printing, it will create them both as the same object. Oops, not that. Go to 3D print, blah, 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 hi. And we'll go with allo tray. Great. So I'll show you the difference if I had selected both things. Go to 3D print. Oh, good. Actually, it's not letting me select two different things at once. Excellent. All right. Well, that's the whole benefit of using two different components. Good. They have started to edge some stuff out. All right. So let's go to the slicer. So I hop over. We're using the Prusa slicer. Again, if you're using Cura, that's fine too. So let's drag and drop our objects. So I got the vessel, plop, and I got the tray, plop. Now, it's going to orient them how it was built in the program, and it was built stacked like this. You cannot print them like this. If you do, it will either try to fuse the two together, or especially if in your print or in your program, the pieces are actually, let me change the opacity here, visual style to hidden edges. And you can see in here, they actually make contact. If you do that and go over to print them, it will print them as one object, essentially. You must make sure you separate them out. Well, luckily in this, you can either do it by hand or here, if you go up to the top of the screen, you have auto orient. Now you actually have to select things to auto orient, but click that button and it'll throw them outwards. And luckily in this case, they both fit on the tray, or they both fit on the table, no problem. All right, so this works well. Now the thing, what's going to be an issue is if I was just printing just this plain vessel, no problem. However, I've got this text on here that will present a problem. So let's go over to our print settings. And for this, I'm just going to use draft setting, make it as fast as possible. That's okay. Double check your print material. If you're printing in PLA, remember that's a lower print temperature, but we have colors or more colors for that. PET, hotter, bond's a little bit stronger. We have fewer colors, but we do have translucent stuff. So right now, and double check if you've downloaded this, double check that you are using Prusa Mark III or Mark III's. Make sure it's using that. Double check that if it hasn't, you need to update that. You just go over to settings and import the correct ones. Now, right now, I've got it set as supports none. Go to slice and see if it gives me any errors, which doesn't always give you errors. So it's going to think about it for a moment. All right. Now it's giving me all this weird. Now it's giving me all this weird view right now because I'm zoomed way out and it's a larger form. Zoom in and you can see that it's actually just all the different layers. All right. But what did I just call? What did I say it was going to be an issue? Overhang. If you look at these, the legend, overhangs in this program are shown as blue. What that means is it could print depending on the size of the overhang. If an overhang is small, it can bridge across. If it's large, it might be a little droopy, but it might still be okay. However, on this, even though the bottom of my vessel is smaller, and it should be able to bridge just fine, the issue is absolutely going to be these holes. Also, this vessel, let me hide the tray. Just trying to hide or change my visual style here. Wireframe, there we are. Looking at it in wireframe, if this internal bottom was flat, might not be a problem. This internal bottom it's built into its own overhang. Even though it is a flat, or even though if it were flat, it might be okay. It's not. It's indented. It's going to try to print the feet and that little tip at the same time. If it's making contact, you might be okay. If not, it can't just print in space. So what you need to do is go to supports. And you've got several options. And in this case, because it's a simpler form, they're essentially the same thing. Usually, if you have a very complex form, you want to go to everywhere. But in this case, we'll just go with support from build blade only. And let me show you the difference. Reslice that. Let it calculate. Now it's got all of these iterations around. These are your supports. Now it's printed a large bridge on the outside only because it's trying to compensate for it having to build a support, and largely because of in the front, it has to support these letters. They just jut directly out into space. That is a straight out 0-degree overhang that doesn't go to anything, meaning that it starts at the body and then just goes out. So anytime it tried to print, it would probably start to droop down at the front. Now, in contrast, look at the bottom of the tray. It's all only underneath. So you're pretty well good. Now, a couple of things about supports, and I'm going to discuss this more in detail, is if you can avoid having your model print supports, that's, I won't say for the better, but it's beneficial. For one, you can shorten the print time if that's what's important to you. Also, if you're using your own materials, it lessens the amount of materials it uses. Now, supports are generally printed much thinner and more sparsely than the actual body is. So in reality, it really doesn't use that much more material, but it can absolutely use more or take up more time. So what can you do to avoid stuff like this? Well, in some elements, it's just unavoidable. The cap here is good. Let's go back to regular form here. And if, say, you had brought this object in, and I'll just select this one and flop it over. If this object were flipped upside down, it's going to take a whole bunch of supports because it's going to have to print this whole internal space. So I go to slice, or it's going to have to support that whole internal space. Lots and lots of supports. Really a pain. Also, it looks like I accidentally moved it outside of the bed. So interestingly enough, it actually had to move on the audio orient, actually placed it outside of the print area. That's problematic. So in reality, what I have to do is move that manually, reslice, and it's okay. So it's all right if those two objects are actually technically nested underneath one another. It's like one is under the other's overhang. They don't make any contact. So that's okay. So definitely consider your orientation, how both the orientation of the actual object and how they relate to others on the print bed. But obviously, having that lid flipped is real dumb. So go back to regular, flip it back on its how as it should be. Now they're not making contact, so it's okay. Reslice again. All right, you're all set. So what about the text projecting out? Can that be adjusted? Yeah, absolutely. You have to go back into the model, but you can. So let me go back, change my settings again, just because I need to actually be able to see what I'm doing here. Visual style, we'll go with visible edges only. All right. So what I would need to do here, oops, get a little confused on the view methods for different programs. All right, so let's check the extrusion. Where does that come in? That is that one. So for one, what I could do is edit that feature. Where'd it go? There we are. So one thing you could do is maybe use the let's see here. If it lets you, you could use the taper version, the taper. But it doesn't because apparently it's over a rounded surface. Doesn't let you taper it. So that's off the table. Another option. Well, let's try putting a fillet or so around the surface. Select the whole thing and let's shake a really tiny one. Let's say 0.2. See if that'll calculate and just completely crash the computer. It's always the fun of using the this kiosk. All right. So maybe something a little bit larger, but as I zoom in, you can see what's happened here is I have rounded those letters ever so slightly. Probably let's go with something a little bit larger. So let's try 1 then. Make that a lot larger. Error. Yep, of course it errors out. can't go that large, so maybe 0.5 will let us do it. And this is why it's important to use, it's sometimes important to use the numeric input rather than the slider. All right, it's still not going to let me. There's too many complex shapes on here. I was hoping it would let me put a fillet on those, but not. So with text, it gets really difficult because there's a lot of little curves and such. So let's cancel out of that. I could do a little bit, but it wasn't going to let me do much. If this were, say, more of a drawn feature, you would, dang it, keep doing that. You could try to put a fillet or chamfer on any of this and try to round it all over. That might allow you to not have to put a support on there. But in this case, you're probably just going to have to. It's unavoidable in some cases. It's just a method for working around. So, all right. So this would be okay. So it does have to build a stack up that way. As I zoom in, you can see the actual layers much more clearly. And again, these are much further apart simply because I have it on draft as a setting. So it's going to go as fast as it can. Now, you can adjust these, but for the most part, I would say, unless you're really trying to do some really detailed forms, I would just leave it as it is. There's no real reason to change your, sorry, I keep getting my orbit views mixed up when I switch back and forth. No real need to change the settings on your supports because they're automatically designed. Let me get in close here and you can see. Looking at the views, so as I zoom in here, you can see the individual layers. There's a color change in these. Now, in this case, the bright green. Look over at the legend. Yeah, it uses quite a lot of time printing these things. As printing this, wow, printing this whole thing is going to be an 11-hour print. I can fix that a little bit with lessening the infill, stuff like that. But looking at the legend, it adds an hour and a half to this print just printing the support material. So that's where I'd say like you can really save some time by making some small adjustments on your print. The other part is the support material interface. This is the darker green. This is where the support material contacts your object. And that is printed in a different method so that it breaks away more readily. Now, is that going to mean that it's not going to affect your model at all? No, it's going to distort it ever so slightly at the bottommost level of that print part. But it will automatically print out, or will automatically print it in a different manner, meaning what will happen, and most likely, it'll kick the fans on a little bit more so it cools more rapidly, so you get less bonding between that uppermost layer of the support and the lowermost layer of your actual print. So when you look at it legend like this, you can really see like, okay, this really builds up fast. If I could shave any of the support material down, you can save a lot of time. Now, on a longer print like this, you're going to let it go overnight anyway, probably, so meh. But if that is a major issue, we can go into the print settings, looking at support material. Now, double check. One thing that does irritate me, and you don't actually notice it, Prusa Slicer does have tabs here for simple, advanced, and expert. It hides stuff that aren't necessarily, you don't want to accidentally click on and such. So right now the default is simple. Switch to advanced, and you actually get all your settings. Expert, more settings. I wouldn't bother with anything above advanced. But what you can do is you can adjust things like the pattern spacing. What that does is it just makes, rather than the support materials being so tight together in that zigzag pattern, or in this case, it's a grid pattern, you can also create different patterns. In this case, let's say rectilinear is usually pretty good, but let's space out the pattern spacing, and let's say make that 5 millimeters. All right, go back to plater, reslice, and it's going to recombobulate here. It hopefully doesn't crash again. Thinking. Come on, buddy. I believe in you. Oh. Had to reslice and I couldn't see it. All right. So the layers are the same. However, what has changed geez, too fast, is how wide the spacing is between the walls and such. So as I zoom in a little bit more, zoom in, dang it, in I say. Oh my God. Okay, so now you can see a little more clearly how the pattern has changed. But if I go to the legend, now under support material, it says an hour 9. So I just saved over 30 minutes, or sorry, math was a little off on that one. Nearly 30 minutes off of my print time. Now, it's still going to be a long print, but just showing you that some iterations, or you can change some of the settings, and that can save you time on your prints. So, all right. Let's zoom all out. And obviously from there, you would export that, get it prepped, throw it on there. Okay. So the other thing I wanted to show y'all is that's the briefly applied version. Is the actual overview, and this is directly from an article, again from All3D. Really useful article, but I just wanted to give you the actual application information before briefly going over this. I'm going to put this onto Blackboard so you can, or I'm going to save it as a PDF, and of course you can also find the link to go over this in more detail. But this overview is really what we just discussed, but in a much more detailed manner. So things like, where do you need them? As I just said, you have overhangs, issues that anything that flares outward in a way. If it's a taper, if it's something that's a graduated taper or so, again, I have markers for that. If it's something akin to, something that actually tapers upward, anything like that, and your body is over this way, obviously that's going to be a non-issue. However, those are all, if it goes outward, depending on the angle, the body is out there, out there, out there, out there. It might need to create scaffolding. It might need to create, I guess it's more of actual zigzag cross, something like that. Usually, if it's something around, I forgot what letters I was using. Those are letters, numbers. There you go. Usually, if it's anything over 45 degrees, it becomes an issue. Because anything like that, it's going to want to start to flop over anything else. Especially important if your object curves out and away. So again, your object is out this way, because as it slices the layers, obviously, that spot out there, it can't exist without supports. It's going to just squirt filament out into an open space. So as it creates these supports up, often it can just create the supports directly under the form, and just be a little bridge there. Other times it might need to support a lot more, depending on the form. That's all. So it really just depends on how far they're out. The other thing is, like it shows here, flat 0 degree or 180 degree forms or go straight out. Because if it's at least there's some kind of a curve, it can work with that, at least a positive curve. If it's flat out, it's going into no space and then stopping and coming, the print head is going out into space and then stopping and coming right back. There's nothing for it to support to. At least here, like on this H frame, at least it could possibly bridge between the two edges here. Then you might be okay. You might be able to get away with it. The overhang on this Y, it might not need supports. This T definitely will need supports. So again, as it says, anything over 45 degrees often will. 60 degrees, yeah, it's going to need to build some sort of at least little print or a little support there. I'm just going to briefly buzz through this. Again, this will be available for you to read in more detail. And this shows you exactly what happens. You get spaghetti, or often called spaghetti, or yeah, you're just making a big, nice noodle nest there. Because there's literally nothing for it to stick to, nothing to support it while the filament cools. But like I said, depending on the space, it might need supports, it might not. If you're trying to bridge across a gap, if it's small, should be okay. If it's larger, you definitely are going to need supports, depending on the clarity of your form. If it's internal and it doesn't really matter, well, there you go. And if you don't ever see it, who cares? As long as it actually prints, you might get a little bit of sagging. And again, yeah, you can test these printers. You don't need to test these. I've already run them all in, but you can find from sites like printer test objects that will do exactly that. It'll test how far your printer will go at the current settings with no supports. It'll show you where your fail rates are, stuff like that. It is super helpful to have stuff like this. And again, like I said, what are the benefits or rather issues with printing supports? Well, yeah, there's more time, there's more material involved. But honestly, like I said, these standard spools of material, they're about a kilogram each. And I know that really means very little to you. The amount that you're, quote, wasting by printing supports, it's really not a lot. Now, the issue, of course, and we'll discuss this at a later time, is the actual material waste when it comes to sustainability and such, and that if you just throw it in the trash, you're just adding plastic to the landfills and such. So that, of course, is an issue. But as far as like the actual like monetary cost upright, it's really negligible. And again, the other thing, you saw how it increasing printing duration. You saw how much time I was able to shave, even though on a 12-hour print, saving 30 minutes isn't really that big a deal. But by just adjusting some of the support parameters, you can really shave a lot of time off. And if it comes to that, you don't actually have to print supports, you can really take some time off. And yeah, you got to takes extra time processing. And now they're showing something that's been printed in resin on an SLA printer. Still have to print supports. Same deal. And often it's even more important on SLA because at least the filament, you have the benefit of it already being a physical solid that is being partially melted, partially softened. With SLA printing, it's a liquid you're trying to harden. There's very little to no bridging in space on an SLA print. For a filament, yes. Yeah.
So do you have to like trim it off like that? Or
yes.
Oh, okay, I thought it was something you could peel off.
With and the question being that do you have to actually physically trim it away? With SLA prints, yes. Mainly because they'll leave a bunch of little nubbins if you just break it away. If you've ever put together like a plastic model kit that's on a you get all your parts on a big tree and you have to break them away. If you just tear them away, you're always left with a little bit of tear out on your actual object. If you cut them away, it leaves a much cleaner surface. Now with the filament printers, there tends to be a little bit more clean breakaway because as you saw on the slicer, let me zoom back in again. It actually prints an intentional separation layer between them, and it tends to break away a little more easily. When it comes to the resin prints, yeah, it tapers them a good amount, so it's trying to minimize the amount of surface area it's actually making, but yeah, it still requires some cleanup. The other aspect is certainly damaging the metal, and that's what I was saying. If you can avoid it, definitely avoid it, but sometimes it's unavoidable. If you're printing something that has flat surfaces that are overhangs, you might be able to reorient the object so it's printed better, but that's going to get into orientation as it relates to the strength of objects, which we'll get into soon in this class as well. But as you can see, you can break it away and you're still left with an okay space. It's not that big a deal, but depending on the detail, if you're trying to print like minifigures or something much more organic, it shows up much more readily. If it's something that's more architectural or geometric, you're pretty well okay. Plus, you can always sand and file, actually physically process the models either way, regardless of the material. And what I was going to say about a little bit like on here is the difference in the support types. Now, for resin printing, you have these tree types. They look like roots growing all over it, or you choose your reference, your metaphor reference there. But you get all these kind of weird shapes because resin printing can be so much more fine. But again, remember that it can take longer and it's much more expensive, but detailing is much higher. The other version is like this, linear or accordion type, which is what we'll be printing with the slicer program, or with Prusa slicer. This is what you would call accordion or linear type. Again, you can actually change within the print settings the actual feature. So in this case, rectilinear, maybe I change it to rectilinear grid or honeycomb, but I'll just show you what that looks like. Just changing that up. Let it think, let it think. There you go. You don't really see the difference outright, but let me see if I can zoom out a little bit and you can see a little more clearly. Oh man, too close, too close. By looking straight down, you can see, there you go. And then of course I can just slice down through here and you can see the honeycomb pattern emerge. So you can really open up the spacing with playing with different patterns and different pattern spacing. And actually, speaking of, I didn't look at changing that up. Actually added time to the support material. Went up to 1:20 from 1:09. So even changing those around. And again, different ways of printing. Like I said, the filament type with these slicers, it builds in breakaway supports. So that's not really a big deal. One other one, we don't have this option, but it is a really cool option. This is my push for us getting the multi-material units. Is they do also have, even for filament, dissolvable supports. So if this is a really intricate thing that say needed supports, like on the inside, I'm sure you may well have seen things like really intricate prints of like rocket motor models and things like that that have all of these generated chambers within chambers. There's no way you could get pliers or stuff like that inside to remove print or remove support materials. Well, one option would be dissolvable structures. And of course, the other option would just be designing it so that it doesn't need any supports, but that's another discussion. And then most parts you can just break away, but I will warn you right here and now, be very careful breaking things away, no matter what the material is, because they end up very sharp. I have seen many injuries, luckily not in class, but on them internets of, well, model looked good, now it's got a lot more red that I got to clean off of it. So, especially prints that take, you actually have to cut some of the pieces away, like sometimes the breakaway doesn't work as well. You actually have to use like a razor knife or something. Remember, always cut away from yourself and never try to chisel toward yourself, because where will that go? Inevitably, it's going to end up in your hand. So never cut toward yourself. Benefit of these, at least off the build plate. Remember, you can flex the build plate and it'll pop off that way. You still have to remove the supports from the object, but that's an issue. All right. And then, yeah, you minimize what we already discussed. You can minimize, I don't know why it's showing all of these super organic things. You can minimize how you design your objects. You know, we talked about like changing the model itself. If I were to, oh, I forgot that that's still up. So this is pretty minimal. This, yes, it has a curved bottom, but it's very light. You could adjust this for like a chamfer, or this whole side of the vessel is already basically one straight chamfer, so it's much less of an issue. If this were more rounded, yeah, it might try to generate more supports. But just making small changes to your model, things like, all right, this whole internal space, basically, if this is all just a straight extrude directly through, it might have to create supports internally. However, putting enough chamfer angle and such like that on here, it minimizes the actual amount of internal overhang, and it becomes a self-supporting structure, and it no longer needs additional supports. So you can make changes to your models and such like that. And we already went over this, but this article waits to the end to discuss orienting your structures, something like we're working with right now. If it has a large flat surface and an open space inside, point the open space up. Leave the flat space flat against the work table. Now, one quick thing on that. I'll circle back to that. And same thing with like large organic, large overhangs. Yeah, it's going to create this big long overhang. Now Now, the problem with something like this is if it has to create a big, tall support structure. Remember how I said that support structures are much thinner, so they take up less material? That also means they're much more delicate. And the way that an extruder head works, it can very easily, especially when this gets taller, it's physics, it's a lever. The taller something is, the less force it has to, and then less force it takes at the top to put a much greater force at the bottom. It can very easily snap that support off. Once it gets all the way to the top or a lot closer to the top, it can snap it off at the bottom and ruin your print. So in this case, it's actually better to angle your print a little bit so that it doesn't have to create this big tall stack here. And it can actually create overhangs, or it can actually create prints and supports elsewhere. Now, is it going to try something like this? Is it going to create a whole bunch of other supports elsewhere? Yeah, it will. But they'll be self-supporting. Yeah, you start getting into supports that are better supported. Oh my God, I'm still going to lose my mind here. Yes, that is actually a thing. And mainly because you just want to avoid things like this, that it's a super tall thing. And I've seen prints of like knife handles and things like that. You don't want to have to orient it all the way straight up because it doesn't take much force for that print head to knock your whole print off, and then you've just ruined a 12-hour print. Not only have you lost the material, you've also lost a lot of time. So just consider those kind of things. And there's a bunch of other details on here. I highly recommend looking through this article. I'm going to link it onto our page. Auto-generated. I don't like using auto-generated supports. You can automatically generate them, but I don't like leaving it on because it kind of forces you to use supports where you can dial them back. And again, it can create, some of these will have to print internal supports. That's fine. Again, that's getting into a lot more stuff. We haven't even discussed controllable supports yet, but this is a really good article that goes into a lot more of that. And here is talking about the spacing. I just leave those at the defaults. I've yet to run into that really being an issue. So I'd leave the spacing and supports, or sorry, the interspacing. And what that refers to is, oops, going back to this screen, that's referring again to where the, it's got to catch back up where we're working. That goes back to referring to where the supports actually make contact. And for some reason, it's not showing the supports right now. Oh, I accidentally hid those. Forgot that. It's just referring to contact spacing. You can play with those, but I've really not run into that being an issue. I wouldn't mess with it. Yeah, we already just went through. Cura has more options. Prusa just has those 3 options for patterns. As you saw, pattern can slightly change the timing that it takes, but play around with it if you like. But ultimately, just know that depending on how you actually orient the object, come on, catch up, computer. Orient the object within your slicer program, as well as being able to make small changes to your actual design, can minimize the amount of supports your model actually has to have. But sometimes they're unavoidable, and at least you can alter the amount of supports you will require. Just know that sometimes it's necessary, and it's not like it's that wasteful, but it can take more time. If you can reorient your model or make some minor changes to your model to minimize that, highly recommended. So I'll put that article onto Blackboard, but just know that that is the article on all3dp.com. Always a good resource for stuff.